All right, hey there, Earth Science students. Today we're going to be talking about the atmosphere. So first off, let's talk about what is the atmosphere. So the atmosphere is a layer of gas that surrounds the Earth. It's our least dense layer of the Earth. It's on the outside of the rocky part of the Earth. Right now, you are currently in the atmosphere, right? We're standing on the surface, and this gas surrounds the Earth. We're at the lowest level of the atmosphere called the troposphere. And in the troposphere, that is where we are going to be experiencing weather. And that's what we're going to be talking about for the rest of this unit. So first off, let's get a little understanding of what is weather. So weather is the current atmospheric conditions of a specific place and a specific time. So like, what's it like outside? Is it cold? Is it raining? Is it snowing? Is there a tornado? What is happening, right? What's going on outside? That is our weather. So you've probably also heard the term climate thrown around as well, right? So weather and climate are a little bit different, and that's what we're going to be expanding on later on in this unit. So how is weather different from climate? So climate is long-term study of weather patterns, usually temperature and moisture, whereas weather is our short-term stuff. So what's happening today? What's happening 10 days from now? Climate is more like what's going to be happening 10 years from now, or what happens on a yearly basis in a particular area. So what is the major cause of weather? It's the uneven heating of Earth's atmosphere. So the Earth is a ball, right? It's an oblate spheroid to be exact, but it's a ball. It's a sphere. And spheres get warmed up, not all at the same rate, depending on where you are on the sphere. They get heated up unevenly. And those differences in temperature are what's going to be causing our weather, because everything wants to be at an equilibrium, right? And if we're heating something unevenly, continually, it's going to be hard to reach that equilibrium. And weather is kind of like the planet working out towards that equilibrium. So let's talk about the atmosphere, because that's where all of our weather is going to be occurring. So on page 14 of your Earth Science reference table is an entire chart showing you our atmosphere. And it's broken into 4 layers due to changes in temperature. So let's take a look at it right here. So here we have the exact chart that you're going to be seeing in your reference table. So if we look down here, we have sea level, 0. That's the bottom of our chart. Our first layer of the atmosphere is our troposphere. Our troposphere is the layer that you are currently in. That's where we are right now. We are in the troposphere of the atmosphere. It's the lowest layer of the whole atmosphere. Then we go up, we've got stratosphere, mesosphere, and all the way up to thermosphere. So I got a cool little chart here that kind of shows you a little bit about each of those layers. So right down here, you can see the troposphere. You can see every part of the land part of Earth is in the troposphere, right? Even Mount Everest doesn't go up to the next layer, which is the stratosphere, right? Even commercial jets just basically fly just above the troposphere, into the stratosphere a little bit, but not a whole lot. Our next layer, the stratosphere, is an important layer. It contains a gas called ozone, which we're going to see is very important. And then finally up here we get up to our mesosphere, and this is where we've got meteors coming in and burning up. We've got rockets. We've got all sorts of things. That is a much higher layer of the atmosphere. So the 4 layers from the bottom to the top, just like I said, were troposphere, stratosphere, mesosphere, and thermosphere. So the ozone layer, that is going to be in our stratosphere. Ozone is a gas that prevents ultraviolet radiation from reaching the Earth's surface. And this is important because UV radiation can be dangerous, right? It can cause cancer, it can destroy crops, it can, it causes damage to things. So the ozone layer is there to protect us from all this dangerous ultraviolet radiation. So ozone is found between 12 and 50 kilometers up in the atmosphere. Which layer is it going to be? It's going to be the stratosphere. That question's in your notes. You probably also saw some layers that had pause at the end of it. These are not so much layers as they are points. They're just kind of like lines that are dividing the different layers from each other. They are boundaries between the atmosphere layers. Temperature stops or pauses and then starts to increase or decrease depending on what it was doing before. So for example, between the troposphere and the stratosphere, temperature is decreasing in the troposphere. When it gets to the tropopause, it now starts to increase through the stratosphere. So you can see that right there on this chart. See, we've got our temperature right here in the troposphere decreasing, decreasing, decreasing. It hits the tropopause and it starts to increase throughout the stratosphere. All right, we got a couple other parts to this chart. So over here we've got our water vapor, right? You can see that water vapor pretty much only exists in the troposphere. So that's the only layer that we're really going to get any significant clouds or even any significant weather. Atmospheric pressure decreases for the entire time. It doesn't go back up and down, nothing like that. It continues to decrease the entire time you're going from sea level all the way up into space. Our air pressure is just going to continually decline. And we already talked a little bit about temperature, but I want to go a little bit further into it. You can see how in the troposphere, my temperature is decreasing. Then it starts to increase in the stratosphere, and then it decreases in the mesosphere, and then increases in the thermosphere. Now, I want to talk about the reasons for that. Why is that happening? So we understand that as we're going through the troposphere, the air is starting to get thinner, right? There's less absorption of any kind of solar energy happening in the troposphere, and that is why the temperature is starting to decrease. Once we get to the tropopause, this is where that gas, ozone, starts to show up in our atmosphere. And ozone is really good at absorbing ultraviolet light. Now, when it absorbs that light, it takes on that heat. So that's why the stratosphere starts to heat up as we go further and further up through it. So our concentration of ozone starts to increase, and so our temperatures are going to start to increase throughout the stratosphere. Once we reach the mesosphere, there's no more ozone. So there's not as much ultraviolet radiation or even any kind of solar radiation absorption going on in the mesosphere. So my temperatures start to decrease. They start to decrease. Then it hits a point where we are now at the very outside shell, essentially, of our atmosphere. So it's receiving the most direct sun rays, insolation. Any kind of stuff coming from the sun, any type of radiation coming from the sun is getting a direct hit onto our thermosphere. So that's going to cause the temperature to increase. But I want to offer a caveat to that. I want to say that if you were to suddenly be transported in the thermosphere, it would feel cold. It would not feel warm to you. Remember what we said about what heat actually is. Heat is atoms moving quickly. So these atoms are getting hit by the rays from the sun, from the radiation coming from the sun, and they're moving really fast, but there's not a whole lot of them. And because there's not a whole lot of them, there's not a lot of stuff to transfer that energy to you or to anything else really. So as you're up there in the thermosphere, you're not going to feel warm, even though the atoms are going to be zipping around you and have a whole lot of energy. There's going to be a high energy area. All right, and I just want to get back to weather occurring in the troposphere because this is the layer of the atmosphere that contains the most water vapor. I want you to make sure you have that in your notes. And this is what we're going to be talking about for the rest of the unit. Most of the stuff that we're going to be talking about from here on out is going to occur in the troposphere. So we're going to be talking about all different kinds of weather. All right, that does it for this video, and I will see you on the next one.